Hi guys, we're going to extend our learning on writing formulas to using polyatomic ions. There really is no big difference here. You're still going to pay attention to the charges. The thing that you do have to pay attention to is that a polyatomic ion is actually a team. It's a group of atoms that work together and they stay together, and therefore you apply one overall ionic charge to that entire team of elements. So on the screen here, we have a couple of examples. I'll just take some really common ones that you'll see us work with several times. NO3 is the nitrate ion, and it has a -1 charge for that entire ion. CO3 is the carbonate ion, and it gets a -2 charge applied to that entire team. The special thing about that is then when we get to writing the actual formulas, if we end up needing more than one of that polyatomic ion, we have to use parentheses around the entire polyatomic in order to keep it separate and show that any subscript that we add applies to the entire unit. Okay, so another thing to make sure that you're paying attention to, and you always have that periodic table and that ion chart to use on any quiz or test, but you have to read carefully because one letter makes a huge difference. For example, NO3 is nitrate, but one oxygen less, NO2 is nitrite. Notice they both have a -1 charge. So that gets kind of tricky. You do have to be super, super careful. Read carefully. And, make sure that you're not mistaking it for nitride, which would be just the single N alone with no other. That's a monatomic ion. Phosphate, PO4 with an overall -3 charge. Phosphite, PO3 with an overall -3 charge. Okay, so just go ahead and glance over at your ionic charges chart on the back of that periodic table. You'll see a bunch of those that you see on the screen here and then others as well. So when we write the formula, again, remember we're still doing math. We are still doing math. What we're doing is the compound has to have an overall charge of 0. And so the reason that we use the subscripts is to multiply the charges on both sides if we need to, in order to make sure that we have as many positive charges as we do negative charges. So here's calcium nitrate, for example. Calcium has a +2. Each nitrate, each NO3 ion contributes -1. Well, logic tells you that if you have a number line and you go over +2 and you only had one of those nitrate ions going over -1, that's not going to get you to 0. You need to have 2. And so that multiplier of 2 is what ultimately becomes the subscript. And like I told you, you're doing the math, but you're doing crisscross. This shows you what it would look like if you did it the crisscross way. You still get the same answer. The calcium has that +2. The nitrate has a -1. We do the crisscross. The 1 goes over to the calcium. The 2 goes over and is applied to the nitrate. You guys know by now we don't write the 1s. We put parentheses around the entire nitrate ion, put the subscript 2, and we're done. So it's nothing really that new. It's just that now you're treating a group of atoms as a single unit. And so you have to be really careful about that. All right, so the cation and the polyatomic ion, you've got that chart. Read carefully. Make sure you've assigned the correct charges. Do your multiplication so that your charges add up to 0. The cation goes first and the anion goes second. You use the subscripts, apply it to everything inside of the parentheses if you're dealing with that polyatomic. multiple, and you're done. All right, so let's try one. Aluminum bicarbonate. If you guys go back to the chart, you're going to find aluminum plus 3. Again, 3 plus 3 does not matter what order you write that in for chemistry. Polyatomic ion that is in the formula is the bicarbonate. You look on that chart, you'll find bicarbonate. Be careful, there's also carbonate. Bicarbonate is slightly different. It's HCO3, has a -1 charge. So you guys can see right now that if I only have one -1 and I got 3 positives, I'm unbalanced. I got to get that to 0. So obviously, I need 3. I need 3 bicarbonate ions. 1, 2, 3. 1, 2, 3 -1 charges is a -3 that is added to the +3 contributed by the aluminum. +3 -3 is 0. You'd get the same thing if you did the crisscross. When you do the crisscross, you don't bring down the charges. You have to make sure that you don't write the ones. And you also have to make sure that you write that subscript for the polyatomic ion on the outside of the parentheses to show that it's applied to everything on the inside. So naming is not rocket science. Find your positive ion. You guys are getting so that I think a lot of you can recognize these without even looking at the periodic table. But the polyatomic, you're going to have to find on the chart. Again, read, read, read. Carefully, 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 because there can just be one oxygen difference, and it's the difference between it ending in ATE or ITE. And then if it didn't have any oxygen, if it just had one of the nonmetals in there, and then that's an IDE if it's a binary. So you do have to be super careful, read carefully. Okay, again, you find the cation, you find the anion or the polyatomic ion. You name the cation. Again, sometimes we might be dealing with transition metals, anything in that middle portion of that periodic table. If that's the case, then you have to use the associated Roman numeral. So make sure that those are in there, and then name the polyatomic ion. So a couple of examples here. Hey, go to the periodic table. That's potassium, right? ClO3. Okay, so the temptation sometimes with novice chemists is to say, okay, would that be potassium, chlorine, oxygen? No, chlorine and oxygen are working together as a team. That potassium is my single cation. I take that out. Everything left is working as a unit. So I look on my chart, ClO3. I find it in the, let's see, it's going to be in the -1 column, and that one is the chlorate, potassium chlorate. I was making sure it wasn't chlorite because there's a chlorite as well and a hypochlorite. Okay, on letter B, it is MnOH2. Okay, well here I know manganese, that's in the middle, and oh boy, I find it in my chart, and I can see that manganese has actually 5 possible oxidation states. So what am I going to do? Well, now I got to look at the polyatomic. I've got OH, that's hydroxide. Each OH is a -1. If I have 2 of them, I only have 1 manganese. I know it's going to be manganese 2 hydroxide. Okay, so that's how we do that. Make sure that you write down any questions that you still have, but go ahead and look at the examples in the practice that's provided, and then do the rest. Look back at the examples, see if you can kind of mirror what's being done, and then submit that for your at-home work. Thanks, guys.